Welcome to The Explainer. Today we're diving into a really fascinating architectural evolution. We are going to map out exactly how you can tear a massive multimodal AI environment right out of the cloud and transplant it directly onto your local laptop. Sounds wild, right? Let's get into it.
Think about what we're really building here for a second. We aren't just writing basic scripts. We're essentially constructing a completely closed-loop digital nervous system. Right now, almost all of us rely super heavily on public clouds to act as the brain for our apps. But the ultimate goal for frameworks like Alien API? It's absolute data sovereignty. It's about building an intelligence that lives, learns, and operates entirely under your control.
So here's our game plan for today. We'll start off with the duplex stream vision, take a look at the top multimodal cloud models, and then walk through the three-phase graduation path. After that, we'll talk about securing our data with a VPS, before finally building a standalone local pilot. Let's dive in.
Section 1, the duplex stream vision.
Okay, so what exactly is a duplex stream? Well, it's pretty much exactly what it sounds like. It's an unbroken, real-time loop of audio and video flowing between a human and a machine. We have this observer stream going from you, the user, to the LLM, and a pilot stream returning from the LLM back to you. The absolute game changer here is that by using WebRTC, the AI natively watches your camera stream and listens to auditory submodalities. I'm talking about things like your tone, your pitch, your emotional inflection. It isn't just reading parsed text transcripts anymore. It's literally experiencing the sensory input in real time to guide its actions toward a hierarchy of well-formed outcomes, or what we call WFOs.
This entire vision builds into a continuous orchestration loop. Step 1 is the stream, just a constant pulse of video and audio data. Step 2 is evaluate, where the LLM actually compares what it's seeing and hearing against those well-formed outcomes. Step 3 is execute. If something needs to happen to reach that outcome, the LLM emits a tool call, like maybe opening a web browser or typing out some code. And finally, step 4 is display, which gives you visual or auditory feedback. In your setup, your script acts as the state machine, orchestrating all this, using WebSockets for incredibly lightweight real-time control signals.
Section 2, top multimodal cloud models.
Now, what's really interesting here is how distinctly the top flagship cloud titans have specialized for this. For that initial observation phase, Gemini 3.0 Pro is an absolute powerhouse. It doesn't just look at static image snapshots. It can process hours of raw video footage as a single continuous stream. But if you need strict schema bridges between human and machine, GPT 5.4 Pro dominates with its super reliable JSON structuring. Meanwhile, Claude 4.6 steps in as the ultimate agentic pilot. Its beta computer use capabilities actually allow it to autonomously control a virtual desktop and reason through complex multi-step logic without hallucinating the syntax. And for the developers watching, you're going to love this part. You don't have to wrestle with some bloated tech stack or nightmare dependency chains anymore. These cloud providers now offer incredibly clean REST endpoints. This perfectly suits a modular, vanilla ES6 and Python philosophy. You handle your multi-part data and base64 encoding natively, keeping your whole architecture incredibly lean and completely free of heavy third-party SDK dependencies. Keep it vanilla, right?
Section 3, the three-phase graduation path.
You can kind of frame this whole process as nurturing a biological organism. You don't just start off fully independent. You start with phase 1, the cloud umbilical, where you lean on massive external resources. Then you move into phase 2, distilling that broad knowledge down into localized reflexes. And finally, you hit phase 3, literally severing the umbilical cord to become a fully standalone pilot. That initial cloud umbilical phase is absolutely vital. You're basically utilizing the cloud's unlimited sensory bandwidth, like having Gemini 3.0 process those massive video streams we talked about, to act as the higher brain function. It observes your intent, generates the Python or JavaScript scripts, and most importantly, it logs every single interaction. This telemetry, it's the secret sauce. It creates a highly specialized, totally personalized training dataset that maps perfectly to your specific laptop state.
Section 4, VPS and data sovereignty.
Think of the Virtual Private Server, or VPS, as your digital sovereignty base camp. When you rent a VPS, you unlock this amazing black box effect. By privately installing models, say using Llama, the hosting provider supplies the hardware, sure, but they cannot look inside your encrypted drive. Crucially, this means absolutely no third-party training. Your custom code and workflows never leave that server to be quietly absorbed by some public API's next training run. You even gain jurisdiction control, meaning you can choose to host your digital brain in countries with super strict privacy laws.
Now, you do have a choice to make here. You can go the unmanaged VPS route, which gives you a completely blank Linux box. You install the security, the LLM, the whole shebang. You hold the keys to the castle, giving you the absolute highest level of sovereignty possible. Or you can choose a managed VPS, where the provider actually handles the patching and backups. It's way more convenient, but the provider does retain some maintenance access. It's your classic developer trade-off, right? Total blank slate control versus day-to-day convenience.
And the barrier to entry for all this? It is practically non-existent. For the cost of like a couple of coffees, we're talking roughly $10 a month on services like DigitalOcean or Hetzner. You can SSH in, run a super simple install script for Llama, and instantly have a private brain acting as a secure relay between your local devices and the wider internet.
Section 5. The Standalone Local Pilot.
And this brilliantly illustrates why true local independence is actually possible today. Thanks to the latest mixture of experts' architectures, massive capability now fits comfortably within a standard 16 to 32 gigabyte laptop VRAM footprint. You've got Gemma 4 processing native vision at over 85 tokens a second. You have Qwen 3.5 VL, which is highly optimized for visually identifying UI elements right on your screen, and Llama 4 Scout, a 17 billion active parameter model that boasts a massive 10 million token context window. I mean, that means it can hold your entire Alien API wiki and your whole code repository right in its local memory. Crazy, right?
When you finally reach this graduation state, your local AI completely stops asking the cloud for help. It starts predicting those well-formed outcomes entirely on its own. It gains direct sensor access to your camera and mic via local WebRTC. It executes vision-to-action system calls right on your operating system, totally bypassing the internet. And maybe most impressively, it utilizes on-device LoRa training. It is actually fine-tuning its weights directly on your laptop as you work, adapting to your exact syntax and physical habits in real time, completely off-grid.
So, we've mapped out the entire journey, from a massive cloud-reliant duplex stream all the way down to a highly specialized, locally executed digital nervous system running right there on your own laptop. The blueprint is there, and the tools are incredibly accessible. The only question left as you build your sovereign AI is this: will you take the keys to the castle with an unmanaged Linux box, or are you going to start with a plug-and-play Basecamp? The choice is entirely yours.